Now let me go ahead and return to the notebook. And we will also see how this appears when we plot the numbers, when we plot the vectors. Now I've created some functions that would allow us to create vectors. Let me show you one example of drawing a line on Matplotlib, because with Matplotlib, the way you draw a line on a plot is by creating a sequence of points, XY points, and that gives the appearance of there being a line. So let me show you a simple example. First, I will create a figure and assign a variable AX to the axes of the figure. And by doing this, we can set the limits of the axes, set the labels of the axes. So I'll show you what I mean. And so here I'll do just that. I'm going to have, this is going to be a two-dimensional example. So this is, get rid of that, vectors in 2D. The x-axis will go from -15 to 15. The y-axis will go from 0 to 10. So we'll have the two quadrants of the Cartesian system. Then I'm going to create a sequence of points. So again, how do we plot a simple point? Let's say we have P1, and this will be, let's say, 5 and 5. Obviously, the order is X and Y, always the case, X, Y, and then if there was a third axis, it would be Z. And then to plot this point, it would go AX dot plot P1 0 P1 1. So P0 will be the point on the x-axis, P1 will be the point on the y-axis. Very straightforward. That's what I want to show you. That's the marker. And so in order for us to draw a line from the origin to this point, we need to create a sequence of these points. So something to this effect. This would be, let's say, this is the first point, the second point, this is the third point. And let's just make this 2 to 2, 2, 5, 5, and 7, 7. And I will run this code, copy this code twice. This will be P2. This will be P2. This will be P3. Okay, so we can get a line to go this way. Now there are three types of vectors. There are position vectors that can appear anywhere. There are displacement vectors. A position vector is one where, let me actually show you the pictures, just easier to explain with pictures. So position versus displacement vector. And there's something called a velocity vector. We're going to look at the one that we're doing is called a displacement vector. So a position vector is something like this. It's, for example, the line segment OA, but it is not associated with some origin. Whereas the displacement vector is associated with a position from the origin. Okay. And I'll tell you why I'm bringing that up, because when we do vector addition, we will displace a vector to show you, so we can understand what's going on with the addition. Anyway, what I'm going to do now is I'm going to use a code from NumPy that will allow me to generate like 100 such points, and that will give the appearance of a line. Okay, so instead of doing this manually, I'm going to get rid of these, and I'm going to use a sequence of points to draw, to give the impression of a line. And here's the code. So there's something called linear space from NumPy. So we go np.linspace, and this takes 3 arguments. So you're going to create a list of values, right? The starting number, the ending number, let's say 5, and then the number of values that you will generate from 0 to 5. So if I say 100, then you will get something, like this. Small increments leading all the way to 5. So that's 100 points. That's for the, now let's say this is for the x-axis. So I'm going to go x equals np.linear space 0 to 5, and then the same thing for the y-axis. And I can go back to ax.plot. So the plot method can either take a scalar value, or in this case, a list of values. I'm going to go x and y, and I don't need to do anything else, I believe. There we go. Yeah, for some reason, when you are plotting with with values that are lists, you don't need to supply the additional arguments. But there we go. The reason we're able to see this line is because we have 100 points on this chord, 100 x and y's. Now, what I want to do is I want to show multiple vectors, but I don't want to use this kind of code. So I've created, or I've abstracted away the code. So there is this function that I've created. It's called vec. So I'm going to get rid of these. And it takes as argument the x and y points as a tuple. So points will be a tuple of x, y. Then optionally, the displacement along the x and y axis. And all it's going to do is it's going to, start on the x axis. It will start at the origin. By default, it's 0. It will start at the origin and the stopping position on the x axis. And it will generate 100 sequence of numbers, just like we saw. And then it will return the tuple of lists. So this will be a list, this will be a list, and there will be in a tuple. But we'll convert this to a NumPy array. Why? Because we want to perform the vector addition and scalar multiplication. And a NumPy object will allow us to do that. Then I have another function called draw. So this will create a linear space for a vector, and this will draw the vector on the subplot. So this will take as argument a vector, which will be a tuple where the elements are lists. So basically V will be this. V will be something that looks like this. Okay, a list of values from 0, 0.01, up, all the way to, for example, 5. And the same thing for the y-axis. So when we do math, we really just need 1 point on the x-axis, 1 point on the y-axis. That will give us, for example, somewhere there. But since we want to draw the line, we also have to generate the points leading up to that point. So that's what this function does. That's what this function does, and then we pass it to the draw function. And of course, we can, once we have generated the vector, we can also displace it after having generated it. So if I remove these displacement values, you can see it's just, this is going to be the list of x points along the x-axis. This will be the points along the y-axis. And these are just additions to displace the vector. Then I have this third function, GP, short for get points. I'll show you what this does in a second. Okay, let me remove it for now. Let's just keep things simple. Now I'm going to create two vectors. V sub 1, which will be a vector at the point 0, 5. So I don't need to, once I have created these functions, I have abstracted away the NumPy stuff, and I can just, use simple notation. So V1 will be a vector from 0 to 5. V2 will be a vector. Let's make this one. Well, 0 to negative 5. Actually, negative 5. So this is 5 steps, negative 5 steps to the left, and it will appear. So we'll get a V. And then I'm going to draw these vectors. I'm going to go draw. The argument has to be the first vector, or V sub 1, and then V sub 2. And the draw function needs to know which method to call. So I'm going to use the plot method of the AX object, the axis object. And this is supposed to be 5. Where's it? 5, 5. There we go. Okay. So the reason I set the x-axis to go from negative 15 to positive 15 is because I don't want to move away from this point. It's just easier that way. Okay, so let's see what vector addition does. I'm going to create a third vector. And the third vector will be the sum of the first two vectors. So in order to do this, I need to grab the coordinates of the first vector. So this function, GP, get points, will give me the points of the first vector, which is 5 and 5. And the points of the second vector, so V sub 2. And the way this function works is pretty straightforward. Let me bring it back here. We will take the list from the vector. So remember, a vector in this notebook is a tuple of arrays. So we will take the array in the x-axis, and it will just grab the last element. So the ending number. And the same thing for the y-axis, and then we will return an empty array. Okay. And then, so I'm going to add these points together and then turn it to a vector. I'm going to draw this third vector. And you might be able to see it, but you can see now that the size of this vector is double these two vectors. So I'm going to draw this in a different way. I'm going to not draw the third vector for a second. And what I'm going to do is I'm going to align these vectors. I'm going to stack them up on top of each other, actually. So the first vector will go from 0 to 5. So it'll be a vertical line. And I'm going to take the second vector and draw it on top of the first vector. So this will be 0 on the x-axis. Okay, and I'm going to have to displace it here. So we get this, but I'm going to displace the second vector. So let's also use the colors here. For colors, I can use the, to which function did I add a color? See. So second vector, I will make it red. And the first vector, I will make it blue. Okay. Yeah, these belong to the draw function, sorry. And this will become blue. Okay, now I'm gonna displace the red line by 5 points. I'm going to go y displacement 5. And then when I draw the third vector, I'm going to displace it 5 points along the x-axis. So we can see these vectors side by side. So x displacement equals 5. There we go. So this is what vector addition does. You will get the well, this is what it means. You get it becomes twice the length. So I use this example because the examples I've seen in books were not clear enough. If I type here vector addition, you see examples like this. Okay, or maybe this is clear enough. Or even this one. But by here, displacing it, I think it made it very, very clear.